All right. So, hi everyone. Welcome back. Very good evening to you all. So, can someone just please confirm if I am audible? Let me check myself. So, everyone, just write a quick +1 as a confirmation from your side so that we can start the discussion. Okay, great. So, how many of you were able to solve all the problems, or how many problems you were able to solve? And how was the contest? And I personally categorize this contest from easy to medium level. The first three problems was doable. The last problem, for the last problem, you need to know the advanced data structure, which is either segment tree or a fabric tree. But the entire contest was really very nice. And another important thing, we'll discuss all the solutions to the point. So expecting a very high level attention from you guys. So let's just quickly share my screen. I did third with the memorization DP, but it gave TLE. So what you can do, Shubh, after the session, just paste your code in the comment box, and I will give you the solution. Basically, I will optimize your solution once I get the time. So yeah, let's just go for it. And I guess this one is the best template. So this was a first problem, which is a fairly easy. So you are given a string s consisting of lowercase English letters, and your task is to find the longest palindromic substring that can be obtained by rearranging the letters of s. And if there are multiple longest palindromic substring, we need to find the smallest one. So the very first thing, we are not interested in the length of the longest palindromic substring after the rearrangement. Instead, we are looking for that that longest palindromic substring itself. So yeah, do not get confused with this thing. Now let's just discuss the solution. So let me explain you the first sample input. So here in this case, we have a string s as ABA, then CC and D. So what I can do, I can rearrange its character such that my S is equals to D, then A, and after this, let's just okay. After this, what I can do, I can place a C here. Then let's place a character B. Then again C, A. So here in this case, after this rearrangement, the length of longest, not the length, but the longest palindromic substring is this one. So my answer is simply equals to A, C, B, C, and A. Cool. So how we can solve this problem? So before discussing the solution, let's just discuss the second sample input. This one. A, B, C, and B. So I can rearrange the characters, and so that my string S becomes A, B, A, okay, sorry, B, A, B, and C. So in this case, the longest longest palindromic substring is this one. So this will be my answer. So my answer is simply equals to B, A, and B, right? Here instead of A, I can also place C. But in that case, that string has the maximum length, but it is not the lexicographically smallest. So this is very important thing. We are interested in lexicographically smallest answer. So yeah, that's why we always give the priority to the smallest character. Now let's just discuss how we can solve this problem. So first of all, I will count the frequency of every character, and then we'll start iterating from the smallest character to the largest character. What are the character types we have? So it consists of only lowercase English letters. So that's why from small a to small z. Now let's say the frequency of each and every character. The frequency of character A is C, 6, and the frequency of character B, let's say it is 3. The frequency of character C, let's say it is 1, and the frequency of, let's say, character D was 0 in my string S, and the frequency of character E is 1. So how I will get this value? So for this thing, I will create an array. Let's say the name of this array is count, and it would be of size 26. And here in this array, I will store the frequency of every character. So count of I will store frequency of character I plus A. This I is a integer, and if I add the sky value of character A, then we would be at some character. So frequency of character I plus A in string S. So we have a frequency of character A 6, frequency of character B 3, and so on. So here how I can form the lexicographically smallest answer. And my answer is, what is my answer? My answer is a longest substring, which is palindrome. So for this thing, I will start iterating from A to Z, and for every character, count of I will store the frequency of that character in its string S. So first we have a frequency of character A as 6. So what I can do, I will use the frequency, which is CNT of I for the ith character, divided by 2. I will use this frequency and append these many characters on the left hand side of my expression, on the left half of my expression, my answer. So that another half I will use for the right side, so that eventually at the end I will get an palindrome. So we have 6 occurrences of character A. So I will use three occurrences here. So A. So this is my left half of a palindromic string. Then another 3 occurrences I will use at the end. So A, and A. And basically this is the best solution. Now the next character, which is 3, which is B, and its frequency is 3. So what I will do, I will use 3 divided by 2 and take its lower value, which is equals to 1. I will use one character for the left half, and one character for the right half. So CNT of I divided by 2. So I will place one occurrence of B here and another occurrence of B here. But this time what I can see here, I can clearly it is clearly I can clearly see that frequency of B is 3. So this simply means we have some odd occurrence, right? So here I will use this B. I will use one occurrence of B to make a palindrome of length odd, because here now it is possible, right? So I will declare a variable as per my implementation. This my variable, which is equals to initially hash. It is a special symbol. So what does it mean? If it is hash, then it simply means in my string we do not have any character whose frequency is even. And if it is other than this special symbol, so it means we can form the at the end we can form a string, form a substring whose length is odd and its frequency whose length is odd, and it is a palindrome, right? So here I have three occurrences of B in my string S. I have three occurrences of B in my string S. So here I will use two occurrences for left and right, and one occurrence that we are left with, I will use this occurrence for the middle. Cool. Then we have then we have one occurrence of character C, which is not useful for me. Then we have zero occurrence of character D, so I cannot place any D here. Then let's say we have two occurrence of character E. So here what I can do, I can place one occurrence of E at here and another occurrence of E at here. And this is the greedy solution, and this is the way we can generate the best answer, the lexicographically longest substring after the rearrangement. So I hope it is clear to everyone. Just write a quick +1 if my approach is clear to you. So let me show you the implementation. Okay, so I got a +1 from one participant. What about the other one? So this is the implementation. Find a substring is the method that you need to complete. So first I have taken the length of this string S. Then this is my count vector. Initially, all the count value is equals to 0, and then it store the frequency of every character. And this is my odd character variable, and I have initialized this one with an special symbol. And if we have some character whose frequency is odd, then I will store that character in my odd variable. So my left half of the palindromic substring, initially it is empty. Then I iterate over all the 26 character from 0 to 25, right? And 0 is corresponding to character A, B is corresponding to character, sorry, 1 is corresponding to B, and so on. 25 is corresponding to Z. So that's why from a smaller character to the bigger character. Then how many occurrences of ith character I can use in a left half? So this is nothing but frequency divided by 2, right? And this is the way you can create a string. So basically here I am creating a string with this frequency and this character, and then I will append that string in my left half. Cool. And then after I'm checking if the current character is having frequency odd, so I can use this one occurrence. It's one occurrence to put it at the odd position to make the palindromic substring of length odd. So if if its frequency is odd and the value of odd is equals to the special character. Value of odd is equals to the special character. So this simply means this is the first character whose frequency is odd. So it's best to select this one. Do not select the other characters, because we are starting from smaller to the bigger. So I will select this character and update the value of odd. Now what will be my string right? So my string right is nothing but the reverse of left, right? I will, and I have already preserved the characters for the right half. So my string right is nothing but the reverse of left. So first I have created a string right and initialize this right with left. Then I will simply reverse this string. And if odd not equals to the default character, then I will append this odd in my left half, and this will be my final answer. So those who are asking for repetition, so I guess it is just a waste of time. You can watch the recording of this session once this live is over. Otherwise, the video becomes very lengthy. So now coming to the next problem, but before that, let's just discuss the time complexity. So here the time complexity is no more than order of n. So this one takes order of n at most, because here we are using the frequency of characters and divided by 2. So this function takes the linear time, and how much it is count of I divided by 2. If you have to create a string of length, let's say m, then it would take order of m time. So that's what I have mentioned. So this one will take order of n time at most, and then similarly this one also order of n by 2, or I can say overall the time complexity is linear. So coming to the second problem, this is also a fairly easy problem and doable. So minimum sum. So you are given an integer array ARR. You are also given an equal size integer array change and an integer k. So basically two arrays ARR and a change of the same size and integer k. You have to perform exactly, okay, you have to replace exactly k elements of ARR with the corresponding elements of change. Right here we have to replace exactly k elements, not less, not more, exactly k times I need to perform an operation, that is change ARR of I into change of I. If we perform the operation on ith index, and the goal is to minimize the sum of elements of array ARR. So let's discuss the solution. So let's say we have the size of array as 5. The value of n is equals to 5. So I have two array of size 5, ARR and array change. So I will call this array ARR as array A of size 5. So we have 5 elements. A1, I am using 1 base indexing, but you know how to deal if we have 0 base indexing. Then A of 2, A of 3. Let's write these values a bit separate from each other. Then the corresponding values in array change. So C1, C2, C3, C4, C5. So array change of size 5. Cool. Let's say we have some value of k, which is arbitrary. Now here, consider the scenario. Consider the case when you do not perform any operation. So what will be your sum? What will be your answer? So your sum, or I can say answer, is nothing but sum of entire array A1 plus A2 plus A3 plus A4 and plus A5 if I do not perform any operation. Now if I perform any operation, that is if I select any index and change the value, then how my sum will be affected? So let's say you have decided to perform the operation on index I. So it simply means you have to replace A of I with C of I. Then what will be your sum? So your sum will be C of I, right? This will be the new value. And then I have to subtract the previous value of A of I. So C of I minus A of I. So basically my sum will change by, basically in my previous sum I have to add this integer. C of I minus A of I. Now let's say after this I have selected another integer, another index j, and I performed an operation. So in that case, what will be my answer? My sum, my answer, or I can say my sum is increased by C of j, and I have to subtract the previous value of a. So previously it value was a of j, and I need to add this number. So in this way, this will in this way my sum will be affected, right? And since my goal is to minimize the sum, my goal is to minimize this sum. So what I will do, I will pick k minimum element, right? So let's create an array D. So let's create an array D, and here d of I is equals to C of I minus A of I. This will be my value of d of I. So this one is C1 minus A1, then it is C2 minus A2, and so on. Finally, here we have C5 minus A5. So from here, let's say the value of k is equals to 2. It simply means I have to apply the operation exactly 2 times. So from here, what I can do, I can pick k minimum element, right? I can pick k minimum element and add their value in my variable sum, and I will initialize my sum with the sum of this entire array A. So the sum of this entire array A, and then C of I minus A of I. So I will pick k minimum elements from array D and will add in my sum. So yes, you can also do the same with the help of a priority queue, but in my implementation I have sorted the array. I have sorted this array D. So here is the implementation. This is the method that you need to complete. First I have taken the size of array A. This is my array D. I have created an array D of size n. Then d of I is nothing but C of I minus A of I. Then I have sorted this in ascending order. Then my answer. First I have initialized my sum with the sum of all the elements of array A, and make sure to use the appropriate data type. We have this accumulate function that takes a starting, and basically that takes a beginning iterator and end iterator of vector, and it will return you the sum. So initially my sum was 0. I will initialize my sum with 0, and then I will add the value of all the integer. Then since I have sorted this array D, so I will add the value of k minimum element of array D, and finally I will return this sum. The time complexity will be n log of n. The time complexity is n log of n base 2 because of sorting. So n log of n base 2. So clear to everyone? Shall we discuss, move to the next problem? So now let's just discuss the next problem. Am I audible? So this was the third problem of the contest, and it is also really very nice. And for this problem especially, I am looking for a greedy solution. So if you were able to solve the problem greedily, then this is really very great. And please post your solution, greedy solution, in the comment box. I really want to know if there exists any greedy solution for this problem. So max or min length. So given an array of positive integer ARR, and your task is to find the length of the subsequence of ARR such that the bitwise OR of all elements, bitwise OR of the elements of the subsequence is maximum possible. Now let's discuss how we can solve this problem. But the problem statement is very straightforward. We have an array. We have an array ARR of length n. I need to select some subsequence such that its bitwise OR is maximum and its length is minimum. So yeah, now let's discuss the solution. But here I have solved this problem with the help of a dynamic programming. So the problem named as min or max length. So the very first thing, operation OR is an increasing function. So what I'm trying to say, OR is increasing function. So let's say you have a OR value as 5. Now what if I take a OR with what will be the value of OR 5 or of 5 and y? Let's say we have some integer y, or let's say we have some integer x. So what will be this value? So this value is always greater than or equals to 5. So that's why I have mentioned that OR is increasing function. Cool. So what will be the maximum OR we can have? So the max OR which is possible is OR of all the elements. So A1 or A2 or A3 up to, let's say, or A of n minus 1 or A of n. This is the maximum OR possible. Now I need to select, now I need to know what is the length of minimum subsequence whose OR value is equals to this max OR. So for this thing, I can define a DP. So DP, the first dimension would be of size n, and this is for the index, and the maximum possible OR. The maximum possible OR is max OR, and since I need this index, so I can declare a DP array of some bigger of one bigger size. So maximum OR plus 1. Now also let me analyze let me just tell you what are the constraints here. So here the constraints are like very feasible, which allow you to write the DP solution, or basically any solution that takes a quadratic time. So the value of n can be up to 1000, and the value of element can also be up to 1000, right? So the value of this maximum, or the maximum or value is always, the value of this maximum or is less than or equals to 1000 always, right? And the value of n, we all know it is up to 1000. So if I somehow update the, basically if I somehow find the answer for every state in a constant time, then my overall time complexity would be 1000 into 1000, which is 10 power 6, and this is a feasible time complexity, and it will pass all the test cases, right? If I fill the DP table in a constant time for each value of for each cell, then the time complexity would be 10 power 6. So let's just first define the state. So DP of I comma j, and this will simply store this will simply store the minimum length of subsequence in a subarray from 0 to I, basically in the prefix from 0 to I, such that, or I can say with the OR value equals to this j, equals to j. Super straightforward. DP of I comma j will simply store the length of minimum length of subsequence whose OR value is equals to j, and it is in the prefix from 0 to I. Cool. So what will be my base case? So DP of I comma 0, this will be my base case. If you want to have the OR value as 0, then you don't have to select any element. So then it is 0, right? This will be my base case. Now for all the DP of I comma j, I can initialize this one with I minus 1 comma j, right? As for every index I, we have two options: either include it or do not include it, or I can say exclude it. So basically this is one base case. Another base case that we have, dp of I comma a of I, right? Dp of I comma a of I, this is equals to 1. So let's say if you want the OR value to be equals to a of I, then from the prefix I will only select the ith index, right? So the length will be 1, and so yeah, dp of I comma a of I will be equals to 1. Now for all the other values, so dp of I comma j such that j is greater than 0, since we have already covered the 0 wala case. So this is equals to, so basically this is my exclusion part when I do not include the ith element. So this is my exclusion part. And for inclusion part, what will be the transition? So if I include the ith element, so basically I can write it this way: dp of I, the current index, or I can say from 0 to I, the current prefix, and j, or a of I. So basically here I have, this is the case when I include a of I. So this will be the new value of OR. So I can say new OR. And this is nothing but the minimum that we have so far, because there might be the case when you can achieve this or this new or by do not including I, and this might be the best path. So that's why minimum. So minimum that we have so far at this index j or a of I, and comma 1 plus dp of I minus 1. So from the previous subsequence, in the previous subsequence, I will add a of I, right? So j, right? Here if I add a of I, then my or value will be j or a of I. So I will update this cell, and plus 1, since I have added one element, so its length will increase by 1. So this is my inclusion part. Cool. And definitely we initialize all the values to some with some bigger values. So let's say 10 power 9. This is as per my implementation. But actually you can initialize all the cell values with n, because at most my answer is n when I take the entire array. So this is the maximum answer which is possible. My answer is always less than or equals to n. So that's why instead of using 10 power 9 or some other big values, you can use n. So this is the transition. What will be my answer? My answer is simply equals to dp of n minus 1. That is entire array. The prefix from 0 to n minus 1, and this max or. This will be my answer. This will be my answer. That is minimum length of the subsequence in entire array from 0 to index n minus 1 with the or value is equals to max or. So this is the complete solution, and that will take order of basically the quadratic solution, and basically in the worst case it is 10 power 6. So clear to everyone? So here is the implementation. This is the method that you need to complete. So I have initialized my max or value with 0. Then we'll take or of all the elements of array ARR. Then here I have created a DP array, and with the dimension n plus 1, but actually you don't require to have this as n plus 1, and max or plus 1, and initialize all the values with 10 power 9. But actually we can change this one to n, as we have already discussed. So then I iterate over all the indices, all the values of I. This will be my base case, and this is the case when I do not include the ith element. Then my answer is same as the previous prefix, right, from 0 to I minus 1. So dp of I comma j, this is simply equals to dp of I minus 1 comma j, if and only if I is greater than 0. Now this is another thing where this is basically kind of another base case. I comma a of I is equals to 1. Then again I will iterate, and why I am not updating, basically why I am not written these two transitions over here, because there might be the case when you are updating the value of some j currently, which is coming in future. So that's why make sure to play accordingly. Here in this case, the new OR value is j or a of I. So we are standing at current j, right? So the value of new OR can be some j which is coming in future. So if you update at the same time, then you will get the wrong result. So yeah, the super simple solution which I have already discussed. And finally, this will be my answer. The time complexity is quadratic. So I hope this is clear to everyone. Now coming to the last problem of the contest. And this one also a very interesting problem if you know the segment tree and or Fenwick tree. So in this problem, I am assuming that you already know the segment tree either or Fenwick tree. And if you do not know one of these two data structure, then you may skip the solution to this problem. So good prefix. In this problem, you are given an integer array ARR and an integer k. So here we have defined a function f of x comma length as the count of occurrences of x in the prefix of given array ARR. ARR of 1, ARR of 2, and up to ARR of this length. And a prefix of length len is considered good if for every integer x and y of the given array ARR such that x is less than or equals to y, the following condition hold true. Function of y comma length minus function of x comma length is less than or equals to k, and this k will also be given to you. And here your task is to find the longest prefix such that every smaller prefix of ARR is also good. Okay, that's pretty interesting problem. Now let's analyze the constraint. Number of elements can be up to 10 power 5, and value of elements can be from minus 10 power 9 to plus 10 power 9. And k is obviously less than or equals to the size of the array. So now let's discuss the solution. So good prefix. So the very first thing, let me like write the constraint. So we need to select in two integers x and y from array A. So x and such that x must be less than or equals to y, and this x and y both belongs to array A. Then f of some prefix y comma the length of the prefix and minus f of x comma length, and this should be less than or equals to the given integer k. Cool. So now let's discuss how we can solve this problem. So let's say we have some prefix I is equals to, let's say we have some prefix and which is valid. What I'm trying to say, let's consider we have this prefix from 0 to I minus 1, and this prefix is good. I am assuming that this prefix is good. For every integer x and y, this equality is true for in every prefix. So the prefix from 0 to I minus 1 is good. And what if I add one new element? So let's say in the previous prefix I have added I index I. So how I can check whether the prefix from 0 to I is good or not? So for this thing, since I have added a new element a of I, so I only need to check whether this by selecting this a of I in any case, does some condition violates or not? And if it is, then my answer is no, I cannot move forward. Otherwise my answer, otherwise take me to the next index, I will do the same for it. So what are the possibilities for a of I? So it might be element x or might be element y. So what if this a of I is equals to x? So let x is equals to a of I. So in that case, what we are looking for? So in that case, we are looking for, we need to check if max frequency minus, this max frequency is a variable. Will tell you that what will be the value of this max frequency variable. So this max frequency minus frequency of a of I. So when I say frequency of a of I, that simply means currently we are considering the substring, or I can say the prefix from 0 to I. It must be less than or equals to k. So what is the value of what is the value of this max frequency? So this max frequency this max frequency is the maximum frequency of some element in the prefix 0 to I, such that its value is greater than a of I. Because I know x, I need to select y. I need to select y. So maximum frequency of some element in a prefix 0 to I, and such that, or I can say whose value is greater than a of I. Cool. So this is the value of max frequency. Then another possibility that I have, this a of I can be y. So let y is equals to a of I. So in that case, we are looking for x, right? So I'm checking for the boundary cases only. So minimum frequency, or I can say frequency of a of I, minus minimum frequency. What is the minimum frequency? And it must be less than or equals to k. So I'm checking for two boundary cases. So this minimum frequency is nothing but the minimum frequency of some element which belongs to array A, definitely, because x and y both should belong to array A. So this minimum frequency is nothing but a minimum frequency of some element in a prefix from 0 to I, such that, or I can say whose value is less than or equals to I, right? And here also I can write the equals to wala case, but if at any side you have written the equals to wala case, then that would work. Or basically even you don't have to consider this equals to case, because if you are picking the same value, then the result would be 0. Basically this expression, the result of this expression will be 0 if x and y both are same. So that's why I'm not writing the equals to case. So now the thing is how I can find the value of max frequency and the value of min frequency efficiently. So I can find the value of max frequency and min frequency efficiently with the help of a Fenwick tree either or a segment tree. And these are two basically a very straightforward application of Fenwick tree and segment tree. But before this thing, I need to do a coordinate compression. So what is coordinate compression? I know. So basically, as per the constraint, the value of a of I can be up to 10 power 9, and it is always greater than or equals to minus 10 power 9. So here in this case, we cannot create a segment tree or Fenwick tree of this bigger size. So I will do a coordinate compression. So coordinate compression, it simply says that the maximum number of distinct value that we can have is nothing but the size of array A. So the size of array A is n, which can be up to 10 power 5. So the maximum distinct number that we can have, max distinct values, is always less than or equals to n. So why to create an array of this bigger size, 10 power 9? So that's why I will compress the value of all the elements of array A, right? And will bring it from 1 to n. What I'm trying to say, let's say you have array A, and it's having element 10. Then we have let's say 50. Then we have let's say 99, and let's say we have a 2. So here in this case, the value of n is equals to 4. That is array of size 4. So what I can do, I can assign the values from 1 to n in increasing order of their actual values. That is, I will assign 1 to the smallest integer, then 2 to the second of smallest integer, then 3 next number to the next smallest integer, and this next number to the next, basically 4 to the next smallest integer. So now we have the range from 1 to n, right? And of this size we can create a segment tree or Fenwick tree. And yes, this is the complete solution. And here is the implementation. This is my basic template of a segment tree. So I'm not going to explain you this. So we all know that segment tree perform the point update in logarithmic time and answer the query in logarithmic time. So every time here I have written two types of query: the query for minimum of some particular range and the query for maximum, right? Because we need to find the max frequency and min frequency. Then here we have a constructor, and this is basically the method overloading. So this is the function that you need to complete, not this one, but actually this one. So first I have taken the size of the array array ARR. Then here I will call this method, this utility method that will compress my range, right? So here I will pass this array ARR, and it will basically compress the coordinates, or I can say value. So here in this method, here I am having a map to keep track of the distinct value. Initialize, here I have initialized, basically here I have added key values, and initially the value corresponding to every distinct integer is 1. Cool. Then I iterate over the map again, then assigning the values in the increasing order, and then I'm updating the original array with these values, or I can say the rank of elements: 1 to the smaller element, then 2 to the second smaller element, and so on. And this is very standard technique. And also I will return the size. Cool. So this is my compressed length, and it is always less than or equals to n. Then here I have created a segment tree and a frequency to keep track of the frequency. Then I iterate over all the prefix for the current index I. First increment the frequency of array A, increment the frequency of current element. Now here I am checking two corner cases. If it is less than or equals to the length, then I will query. What I'm query for? I'm looking for y, because here I have considered this ARR of I as x. So then I am looking for y. So tell me the maximum frequency of any element whose value is greater than or equals to ARR of I plus 1, right? That is greater than ARR of I. So it will consider everything, ARR from ARR of I plus 1 to length. So in this range, tell me the maximum frequency in the current prefix. And if it is greater than k, then I cannot move forward, and my length of the good prefix is I, so I will simply return I. And I'm checking for the same when I fix this A of I as y. So now I need to check for x. So for x, tell me the element whose frequency is minimum in the prefix from 0 to I, and its value is in the range from 1 to ARR of I minus 1. Cool. And if it is greater, basically if the value of expression is evaluates as greater than k, then I will return I, as I cannot move forward. And otherwise update this, right? Update the frequency. And finally I will return n if I do not get any case. So yeah, this is the complete solution of all the four problems. The time complexity will be n log of n base 2. So this was all from my end. If there was something which was not clear to you, then I would highly recommend everyone to just rewatch the video, and that will definitely work. So thank you so much for watching this video, and have a good day. Basically, watching this live session. So yeah, have a good day, everyone.